already completed this thing, right? Exercise 2.1 we have already completed.
Yes.
Correct? As we talked about polynomial. What is a polynomial? So it's an expression, right, with one or more variables. And degree of the polynomial is, what is the degree of polynomial?
The highest exponent. I mean, the highest power of a
Exactly.
variable.
Highest power of the variable is known as the degree of the polynomial. And then we talked
Hey!
about the coefficient of polynomial. Then we talked about how to name a polynomial based on the degree of polynomial. For example, linear polynomial, if the polynomial has degree 1, 2, if the polynomial has degree 2, we call it quadratic polynomial, and if it has degree 3, we call it cubic polynomial, right? And then we also talked about monomial, binomial. If there are one term, we call it monomial. If two terms, binomial, right? Trinomial, just like that.
Mom, can you let me one tap?
Okay. So now we will move forward to the next section in this chapter. Okay. So the next section here talks about. One second. I did this or zeros of polynomial. So basically, any polynomial, for example, let's say 2x to the power 2 plus 3x plus 5, right? It is a polynomial, right? So in any polynomial, we have variable like x, correct?
Yes, ma'am.
Yes. So in that, there might be some value. If you put that in place of that x unknown or the variable, then our polynomial satisfies that or becomes 0, right? Turns into 0 if we calculate. So we call such numbers, such value of variables, zeros of any polynomial. Simply means any number that satisfies the given polynomial are called zeros of that polynomial.
Okay, ma'am.
Right. The very basic example of it is, okay, x minus 1, right? X minus 1, right? Now, if you put 1, x as 1, what will your polynomial will be? If you place,
Ma'am, the answer will be 0.
the answer will be 0, right? So, when at x is equal to 1 is the 0 of the polynomial x minus 1.
Okay.
Right. Similarly, for example, if I write a polynomial like x plus 1. So what will be the 0 of this polynomial? If this is my polynomial, what will be the 0? One possible number.
Minus 1.
Minus 1. So x is equal to minus 1 is one of the zeros of this polynomial. Means any number, if you put it in place of variable and it makes your polynomial into 0 polynomial, that number is called the 0 of that polynomial. Correct?
Okay, ma'am.
Alright. Now, here is some example. So, example number 2 we are going to do. So, they are saying they have given you the polynomial and they have given you one number, one value of variable. You have to check whether this is the 0 of this polynomial, yes or no. So, first polynomial is 5x to the power 2 minus 3x plus 7, and you have to check that x is equal to 1 is a 0 of this polynomial or not. Put the 1 at the place of x and solve it and tell it does it turn into 0 or does not turn into 0. Example number 2.
Yes, ma'am.
Page number 32. Yes.
Ma'am, aren't we doing example number 1?
Okay. Example number 1 is basically they have already solved it.
Oh, okay.
Yeah. So that's why I'm taking this one.
Okay, ma'am.
Hmm. 1 in place of x and keep the polynomial same. And solve it.
Ma'am, no ma'am, it's not a 0 polynomial.
It's not a 0 because if we are trying to solve it, we will get, if we solve this, so this will be plus 4, so we'll get 9, right? It's not turning out 0. So 1x, at x is equal to 1, it is not a polynomial of px, right? So I am writing, crossing it out. Okay, next one, check. Is it a 0? Is it not a 0?
Ma'am, it's not a 0 ma'am.
It's not 0. You can clearly see that there is an irrational number, correct?
Yes ma'am.
And all the numbers are real, this rational number or integers. So not in any case we are going to add this to this. So clearly it's a no. It cannot be a 0. Okay, third one.
With golden heart.
Okay, you can tell the third one without solving it. Check. Can we add 4a to the power 4 minus a to the power 2? Can we solve them? We cannot solve it, right?
No ma'am, no ma'am.
No? So clearly. So whenever you get a question, first read the question. Okay, try to apply some of the basic tricks of math. If you can solve it using some basic tricks, then do it. Don't waste your time too much. For example, clearly in the second one you said, ma'am, not a 0 because it's irrational number and we cannot add it or we cannot solve it. So that's why not a 0. Also same in third one, t is equal to a we were checking. So if a to the power 4 and a to the power 2, we cannot add them. We cannot solve them further.
Yes ma'am.
It's not changing to 0. Going ahead. So they are also given the solution clearly. So none of them is a 0. Okay, now. Okay, example number 3. They have given you polynomial x plus 2 and they have given you two options. It's very easy. So minus 2 and 2. Which are the zeros? Which are not the zeros?
Minus 2 is a 0, but plus 2 is not a 0.
Super, right? So we know we write a polynomial like px and then we write it is equal to x plus 2, right?
Yes ma'am.
And whenever we are checking, what we do, we will put the, for example, you have to check at x is equal to 1, right? So what we are going to do is p1 is equal to 1 plus 2, correct? So it means in exam, you're going to write it complete at each and every step if you want to get full marks on any question, right? Next question they have given. Okay, now they're asking, they have given you the polynomial and they're asking you, okay, you have to find the 0 of this polynomial. Okay, so you have to find a number such an x that your polynomial turns 0.
Okay.
Okay, so that's why they put px is equal to 0. Now what is px here in this case, Vivan?
Ma'am, 2x plus 1.
Right? 2x plus 1. So equate 2x plus 1 with 0.
Ma'am, no ma'am, it's not a 0 ma'am.
It's here, because we have to find the 0, no? 0 of px. So we need to find, what they did, they put px, we need to make our px 0. Right? We need such x that if we put the value of x there, my polynomial becomes 0. Correct? So that's why they first equate px is equal to 0. They write the px here and equate it to 0. Now, how are you going to solve it? I will take my 1 to the other side.
Yes, ma'am.
So it will become 2x is equal to minus 1.
Yes, ma'am.
Right? And then 2 is in the multiplication. So it will give me x is equal to minus 1 by 2.
Yes, ma'am.
Right? So now check, minus 1 by 2 is 0 or not. Put minus 1 by 2 in the polynomial. So at x is equal to minus 1 by 2, my polynomial will become 0. Check it. Is it becoming 0? Have we find the right 0 of the polynomial?
Yes, ma'am, we found it.
Yes. Right? So whenever in the question you are being asked to find the 0 of the polynomial, put your polynomial, equate your polynomial to the 0 and find the value of x. That value of x, at that value of x will give the 0 of the polynomial.
Okay, ma'am.
Okay? Okay,
group of waves.
So they have given you a journal formula. If your polynomial is in this form, ax plus b. Okay, it is a linear polynomial because the power is 1 and it is in the form of ax plus b. Then, if your px is this, then you can directly find the 0 by the formula minus b. Your 0 will be minus b by a.
Okay, ma'am.
Okay, and look at this statement. This is the equation for the same kind of equation we use for what?
And for the first exercise.
In coordinate geometry, we use this equation. What is the equation of line?
Equation of?
Line, straight line.
No, I don't know.
Y is equal to mx plus c. You know that?
Ma'am, no, ma'am.
No? Okay. The equation of any line, the standard equation of any line, it is always represented by this polynomial.
Okay, ma'am.
It's represented by y is equal to mx plus c. If you plot the graph of this equation now, for example, if I give you an equation in this form, let's say 2 5x plus 4. Okay, so if you plot the graph, you will get a straight graph in the coordinate geometry.
Okay.
Coordinate space. Okay, it's an equation in two variables.
Okay, ma'am.
Right? So if the polynomial is of this form, px is equal to ax plus b, so you can directly use this formula to find the 0 minus b by a.
Okay, ma'am.
Okay, it is only when the polynomial is linear and of the form ax plus b. Correct?
Yes, ma'am.
Okay. Now going to the example number 5. Now again they have given you one polynomial x square minus 2x and you have to check whether 2 or 0 are its polynomial.
Okay, ma'am.
Okay. So for this you can check it the simple way, but if you get a polynomial of this form, you take the x common in this polynomial. Take x outside and what is left? X minus 2, right? So now check, it's easy to check. If we put 0, my polynomial is 0 because x becomes 0.
Yes, ma'am.
Right? If I'm putting 2, this part will become 0.
Yes, ma'am.
Right? So these both are 0.
Okay, ma'am. Yes, ma'am.
Right? So try to simplify your polynomial if they are in such way. Only in x terms, or you can take common and then clearly check it out.
Okay.
Right? Okay, now we will go to the exercise 2.2. Okay, there are some points that they share, so I'll just read it out quickly to you. A 0 of a polynomial need not to be 0. Okay, so this is confusion is being seen that if you say 0 of a polynomial and 0 polynomial are two things, correct? Are you clear with both of them?
Yes, ma'am. Yes.
Right? Second is 0 may be a 0 of the polynomial. Right?
Okay.
It may be, but it's not mandatory all the time that 0 will satisfy the given polynomial. For example, if I write x plus 3 and this is my polynomial. So if you put 0 in place of x, that is not the 0 of the polynomial, right?
Yes, ma'am. Yes, ma'am.
So this is what this second point talks about. Every linear polynomial has only one and only one zero. And what is the formula of that 1 0? Minus b by a.
Minus b by a.
Right? Okay. Now let's go to the exercise 2.2. Right? So here is a polynomial given to you and you have to find the value of polynomial. Now they are not asking the zero. So they are just asking the value. So in first part put x as 0 and check what value do you get. In second put x is equal to -1 and find what is the value. Okay, so that is the question. Solve it.
And third one is -3, ma'am.
Super. Right, so all these things you have all the values are correct. Second question is you find p0, p1, p2 in each of the following. So in each of the following you have to find the value at, for example, if this is y polynomial, so keep the y 0, 1 and 2 for each. So one part you have to solve 3 values.
Okay, ma'am.
Okay, just have a look at the fourth part, Vivan. What identity we can use here?
Ma'am, x square plus a plus p whole x plus ab.
So no, not whole. A plus b, a minus b is equal to a square minus b square.
Yes, ma'am.
Right? So it will be x square minus 1 square.
Okay.
Okay, check second one. Without solving, look at the sum and tell me. Is it possible for x is equal to 4 by 5 to be 0?
Ma'am, no, ma'am, because pi is there.
Pi is there, absolutely. If it would have been minus, okay, let's say x is equal to minus 1 minus pi by 5, then it would have been a 0.
Yes, ma'am.
Right? Okay, good, super. Okay, now third one. Okay, Vivan, closely look in third one. X square, there is an identity, x square minus a square. I can write it x minus 1, x plus 1, right?
Yes, ma'am.
Right? Now check the zeros. It is easy to check now.
Ma'am, but there are two numbers, ma'am, 1 and -1.
So if you have to put both the number. You have to check at both the numbers. So if you open this x square minus 1 into this, now if you look, if we put x is equal to 1, then this part will turn 0.
Yes, ma'am.
Making the entire polynomial 0.
Yes, ma'am.
If you put -1, so this part will make the entire polynomial 0.
Yes, ma'am. Yes, ma'am.
Right? So both are the zeros of the polynomial. So these are little tricks that can save your time.
Okay.
And give you like quick mental imagination of which zeros are which are the zeros of polynomials. Right? And same thing is in the next question. You do not need to solve. Just quickly check.
X square minus y square is equal to square minus.
Which one are you doing?
And fourth one.
Fourth one, you cannot apply the property. This is x plus a, x minus b.
Yes.
The second number is not same. Right? So we cannot apply the identity here. You directly check.
And
put
for -1 it will be 0, ma'am. And for -1
it will be 0.
And for 2 also it
For
will
2, yes. For 2 also it will be 0. Super. Right. Go to fifth one is very easy. No need to solve.
Ma'am, 0.
0. Right? Okay. Now, sixth one.
Ma'am, no, ma'am.
No. Why? I think it is. If you place m minus m by l in, okay, let's put, this is your l, right? And you put in place of a minus m by l. So l will be crossed out by l,
Yes, ma'am.
and then we have plus m, right? So this
Right.
will be, because it is division, so it will be 0, isn't it?
Yes, ma'am.
So it is a 0 of the polynomial.
Okay, ma'am.
Right? Okay, next one. 7th.
Ma'am, no, ma'am, because there's an irrational number.
But, okay, I agree there is an irrational number. Very good. But there is a square also here. Little square. If here it would have been rational, if in the polynomial if number is given, then you can apply that trick. Here they have given, the value of x is given in under root. So when you will put it in the square, it will change into 3.
Okay.
Okay. Yeah. It will be 3, 1 by under root 3 square minus 1. So what will be the square of 1 by under root 3? Siddhant?
Ma'am, it will be 1 by 3, ma'am.
1 by 3, right? Minus 1. Correct? And 3 will be cancelled by 3. 1 minus 1 is 0. So it is a 0 of the given, minus 1 by 3. Root 3 is a 0 of this polynomial.
Okay, ma'am.
Right? Okay. Now check 2 by under root 3.
Ma'am, no, ma'am. No, ma'am.
No. Super. Okay. Now last one. Polynomial is 2x plus 1 and the value of x is 1 by 2.
No, ma'am.
No. Right. Okay. Now the next question is, you have to find the 0 of all the polynomial given to you. Okay. So for to find the 0, what is the procedure, Vivan? We discussed this. Yes.
Ma'am, I have to.
Equate the polynomial to.
Ma'am, I have to subtract x from 5.
You will equate the polynomial to 0.
Okay.
First step. Yes. So in each of the step, what we will do, we will put our px is equal to 0. Okay. We need to find the 0. So we will equate our px to 0. Our px in the part number 1 is x plus 5.
Answer is minus.
Superb. Answer is the 0 of this polynomial is minus 5. Yes. Next one.
Ma'am, this is 5, ma'am.
5. The root of this or 0 of the polynomial or the root of the polynomial is called, is in the second part is 5. Third one.
Is it 5 by 2?
Minus 5 by 2.
Okay, minus 5 by 2.
Huh? Because if you change the side, you change the sign. You take the 5 to the other side, the plus 5 will become minus
Minus
5. 2 is in multiplication, it will come into division, which is minus 5 by 2. Yes? Okay.
Yes.
Fourth one. Good.
Ma'am, 2 by 3, ma'am.
2 by 3. Super. Next one. Next one is easy. Fifth one.
0.
3x is 0.
0.
Super. And sixth one, the same.
Ma'am, 0, ma'am.
0, right? Okay. Seventh one, this is the same. Linear polynomial of the format ax plus b.
D and I'm mm,
Minus. Fine. Equate it to 0 and 5.
ma'am, minus D, ma'am.
Minus d by,
Minus D by C.
yes. Okay, done. Right? So since we started the class late, so still have 15 minutes to go. Right? So next is that one you are doing. What is remainder theorem, Vivek? Since you are doing this in the class.
क्लास अच्छा था
Ma'am, it is quotient plus divisor plus remainder equal to unit.
Okay, super. So basically, what remainder in normal term, if I ask Vivan, okay, what is 15 divided by 3? What is the answer?
5.
5, right? And we do it 15 divided by 3 and we write here 5, correct?
Yes,
This
ma'am.
is how we do. Right? And this is, I'm teaching you very basic. This is my divisor, this is my quotient, and this is my remainder.
Yes, ma'am.
Right? So if I multiply divisor with how do I get my dividend? This is the dividend, right? So I'll get 15 if I multiply my divisor with my quotient.
And then add the remainder.
Correct. So this is basically a remainder theorem.
Yes, ma'am.
Right. In terms of number, if we do from very small grades, that this is the thing. Now, how are we going to do it in polynomials? Right. So when you see, okay, what is the weird food combo you ever tried that you yourself made? Weird food combo. Tell me.
Ma'am, pineapple with curry.
Pineapple with curry leaf, right? So for example, some people like one of my friends. The idea of McD selling cold drink with ice cream, float coke, right?
Okay.
Again, right? Or same the curry pasta with pineapple. Correct? So similarly, when we get something new now, we try to experiment. Right? We already have a division. So when we have polynomials, we try to put division format into polynomial. We try to check, okay, if division thing is happening to polynomial as well, or it is just limited to numbers. Okay, so that's why here now we are going to learn how to divide a polynomial. The process is entirely same. It's just little tricky. We will see how. So first they have given a very basic example. They have divided a normal polynomial with just one variable called x.
Yes, ma'am.
Okay, so you can write this as simple, just like we write numbers 2x cubed plus x squared plus x. What is the second term of this polynomial, Vivaan?
X, ma'am.
X squared, second term. This is the second term.
Okay, ma'am.
X is the third term. Okay, divided by x. So they separate the denominator for it. 2x cubed by x plus x squared by x plus x by x. So we get this as an answer.
Yes, ma'am.
Right? So this is a basic example. When there is a monomial, because x has only one term now. So if there is a monomial in the division, we can do it by simply like this method.
Okay.
What if it is a binomial or trinomial? Then how are we going to say? And in this way, this is called one of the factor of this polynomial.
Okay, ma'am.
Okay? For example, if I write x minus 1, x plus 1. So x minus 1 and x plus 1 are factor of x square minus 1.
Yes, ma'am.
Right?
Yes, ma'am.
So similarly, when we divide this polynomial with x, we say this is one of the factors. This is the term that we use, or a multiple of this. Now again, there is a example given. So can you solve it? This one. 3x square plus x plus 1 divided by x.
Ma'am, 3x plus 1 plus 1. 3x plus 2.
3x plus 1 plus 1 by x, right?
Yes, ma'am.
Right. Now, okay. 1 second. Right. So this we can write, and what they did is they took common from it. One way is to divide this complete polynomial with each term by x. Second way is what they did is taking common the things that we did in the previous exercise, no? 3x squared plus 3x plus 1. So what they did, they took common in this term. What is common? What I can take common in this term? Sorry, there is no 3. There is only x. What I can take common here?
Ma'am, only x, ma'am.
Only x. So I'll put x, which is 3x plus 1, right?
Yes, ma'am.
And I'll keep my 1 as it is. Now, Divan, can't you see it is looking like remainder theorem? It's something looking like 5 into 3 plus 0.
The plus after, instead of 3x plus 1, there should be 3x into 1.
3x into 1 by?
Ma'am, for remainder, quotient into divisor.
This is remainder. This is remainder. This is Rx. Okay. This is Rx. This is Q was what? Q was my divisor, right? So let's say it's Px or Qx. So Px, 3x plus 1 is my quotient. So Qx plus Rx is equal to this complete polynomial.
Okay.
Right? This is what they did. Okay, so it's become little messy. So I just clear it up. Did you understood or you have any doubts so you can ask?
Ma'am, no doubt.
No doubt. Now, Vivan, solve example number 6 by then. I'm clearing up the report. So, 3x is x plus 3x minus 1. Gx is 1x, 1 plus x. So, try to take anything common in it. X plus 3x square minus 1. Can you take anything common?
3x square minus 1. Ma'am, I can take x common, ma'am.
X common, right? But we cannot put it in that format. If I put, so it will be 3x plus 1, right?
Ma'am, so it will be 1 plus 3x minus 1.
Minus 1. It is not plus 1, right?
Yes,
So we are not getting into that format. So what will we do? We will try to solve it using the division method.
okay.
Okay, let's see how. So in division method, what will I do? I will write the highest degree first. So I'll write 3x square plus x minus 1. Okay.
Okay.
And I have to divide it by this 1 plus x.
Yes. Yes,
So
ma'am.
I will write it as x plus 1 to make it easy. Okay. Now look at the first number. I need to find a polynomial in such a way that this number got cancelled out. So, Vivan, if I multiply my x with 3x, I will get 3x square,
Yes, ma'am.
right? So, I will put 3x square and what will be the whole polynomial? 3x
Ma'am,
plus
now, yes, ma'am.
3x. Yeah, any doubt? And subtract. So 3x square cancels. This will become minus 2x
2x.
minus
1.
1. Now, what should I multiply x with that I get 2x? Minus 2x.
Mm, minus 2, ma'am.
Minus 2, superb. So, I will get minus 2x minus
Minus
2.
1. 2.
Minus 2. 1 into minus 2.
Okay, ma'am.
And we will cancel it out. And we will get, what is the remainder?
Mm,
1.
1.
So, how can I write x? Can I write this is equal to x 3x minus 2?
And remainder is 1.
3x minus 2 multiplied by x plus 1 plus 1.
Okay, ma'am.
Clear?
Okay, ma'am.
Yes, this is my divisor, this is my quotient, and this is my remainder, and this complete equation equal to the polynomial which we got.
Okay, ma'am.
Did you understood how to divide?
Yes, ma'am.
Yeah? Great. Okay. Now we were going to do the same thing with another sum. Okay, let's solve. This is a very important equation. Dividend is equal to divisor into quotient plus remainder. This is your remainder theorem.
Okay.
Okay? This is applicable to numbers as well, polynomials as well.
Okay, ma'am.
And in this equation, always remember that the degree of Rx is always less than the degree of your Gx. Gx is this divisor.
Okay, ma'am.
Correct? Okay, good. Next sum, if you want to for practice. Okay, take example number 7 and solve it.
Ma'am, quotient is 3x cubed minus 1 minus 2 and remainder is 1.
Okay, so let's check it out once. So we will put this into here. So my dividend is 3x to the power 4 minus 4x cube, right? Minus 3x. So it's already in order, so I do not need to change it, right? And we have to divide it by x minus 1, right?
Yes, ma'am.
Okay, so let me change the color of the pen. So now, what should I multiply x with that I get x to the power 3x to the power 4?
Ma'am, 3x power 3, ma'am.
3x power 3, superb. So now you have to multiply this whole thing to this and then write. Okay, So it will be 3x to the power 3 minus, if I multiply this with 1, minus 3x cubed, right? Here 4 will come, sorry, by mistake I wrote it. Yeah? And then we will change the symbol and solve it. So this got cancelled. This will become minus x cubed minus 3x, right?
Yes, ma'am.
3x. Okay. Now, what should I multiply x with that I get minus x cubed?
X square.
X square. So minus x square.
Minus x.
Yeah? So minus x square, then multiplied with x, we will get minus x cubed. Yes. And then it will multiplied with minus 1, it will get plus x square. Correct?
Yes, ma'am.
Okay. So now I'll solve it. So this is this and this become cross. But we cannot add or subtract these two. Correct?
Yes, ma'am.
So what will we do? We will put these term as it is with the variables in higher degree. So I'll put as minus x square minus x 3x minus 1. Okay? Understood so far?
Okay, miss.
So now, what should I multiply with x such that I get minus x square?
X. Minus x.
Minus x. Minus x. Right. So I will put minus x. So it is minus x square. It will become plus x. And 1 will be as it is. Right?
Yes, ma'am.
Minus. So my remainder will be minus 4x minus 1. Now further solve it. What should I multiply with x so that I get minus 4x?
3.
Minus
3x.
4.
Minus
Minus 4. Minus 4. Minus 4. Minus 4 which we multiply, we get minus 4x. So minus 4x plus 4, right? Because minus minus will become plus. Minus plus 4. So I change the sign and this will become 0 and this will become minus 5. So minus 5 is the remainder and this is my quotient.
Okay, ma'am.
Okay? So in this method, you just have to take care of each step. The moment you miss any step means your answer will go wrong.
Okay, ma'am.
Okay? So practice the sum. I'm sure the next exercise will be based on this only. So I hope it will help you in your class now. In your class, you'll be able to easily solve the sum.
Okay, ma'am.
Okay? So that's it for today. Yeah, I hope you enjoyed the class.
Yes, ma'am.
Okay, darling. So we will meet next time. Take care. Bye-bye.
Okay, ma'am. Bye, ma'am.